Okay, you picked up two things when you came in. This bright yellow one that looks like this. Now, this I put on cardstock. I did not put a page number for it to go in your ISN. I mean, you can fold it and keep it in there if you want, or you can keep it in a folder. I wanted you to have something that wasn't in your ISN that you could use as a reference as we go through the rest of Unit 5. Next week, you do have a test on Unit 5. It's not all of Unit 5, but I didn't want to wait until after spring break to test you on all of it, so we're going to test you on a little bit, then we're going to test again after spring break. But what Unit 5 really is about mostly is trig identities, okay? The reason we did 5.8a first is we really didn't need identities for that. We were solving trig equations, but we just needed isolation and factoring. We didn't need any of these identities. Now, this is a pretty comprehensive list of the most used trig identities. We are not going to use or discuss all of these, but we will at least do something with most of them. The reason it's on a reference card is because at this point, I don't expect you to know all of them. Do I expect you to know some of them? Yes, absolutely. You already know some of them. Look at the reciprocal identities up here at the top. You know those. Sine is a reciprocal of cosecant. Cosecant, like you know those, okay? Those are actually identities. You know the quotient identities. Tangent is sine over cosine. Cotangent is, like you know that whole first row already, at least you should. So you shouldn't need the reference for that. That's the first part of what we're going to look at today. Then as we go through the rest of this, we'll talk about these as we go down the list. This is yours to write on, use, whatever. When you take a test or a quiz, I will give you like a classroom version of it that doesn't have any extra writing on it. But if you want to write all over whatever you need to put on this to make it yours, that's what your notes and stuff are for. Okay, we're good? All right, so let's look. So just keep this handy. As we go through on, I tried at least, on most of the notes that we have, the sections that we're talking about will also be at the top of the notes, but you don't always want to have to flip around in your notes every time when you just want to look at the sheet. So just keep that handy. All right, this is going on page, whoops, nope, we were already there. This is going on page 102 when we are done. So these are just the super basic ones. So let's talk about what a trig identity even is. So a trigonometric identity is an equation. What makes an equation an equation? An equal sign, okay? Just like sine equals 1 over cosecant. That's a little equation. Involving trigonometric functions that is true for all values for which every expression in the equation is defined. So there's just different ways these functions are related. We can use tangent as tangent is, or we can use tangent as sine over cosine. And as we go through and solve equations, where, like I said, the ones we just did, we're just isolating and factoring, but there may be some that are set up where we have to use some of these identities to get it to a place where we can isolate and or factor. Okay, so it's a way to manipulate things with different equal equations, all right? So to help evaluate functions, so when we're doing this, we're going to simplify expressions, we verify identities, and most importantly, solving our equations. That's kind of our goal, but we got to get through how to work with these and what they look like, and then our end goal is to be able to solve equations with them, okay? All right, so like I said before, your quotient identities, we already know those, and we already know our reciprocal identities, so we are good to go. We're just going to use them here on this first page. Now, when you're doing these, you want to make sure that you actually read the directions. I know I'm asking a lot, but it's very important. This says use the quotient and reciprocal identities, because you may be able to use other identities. That's not the purpose of what we're doing right now, okay? So make sure you're doing whatever the directions say, even if there's a different way to do it. So this first one, super easy. It says if secant theta equals negative square root of 30 over 3, find cosine theta. All right, how are secant and cosine related? They're reciprocals, okay? They're reciprocals of each other. So secant is 1 over cosine, or that's the same as just a reciprocal. Like, I don't have to put 1 over that thing. I just know that if this is secant, then the cosine of theta is equal to the reciprocal of that, which is negative 3 over the square root of 30. Okay? Now, I can't leave it like that. But sometimes we find something and we have to find cosine, but what we really want is the reciprocal. So before you rationalize, always make sure that you don't want in the end to take the reciprocal of it, because if you do, you might as well not rationalize, because you're about to flip it over and make it okay anyway. Does that make sense? But with this, we did flip it over. That's how we ended up with it. So we do need to rationalize. So this is going to give me negative 3 square roots of 30 over 30. Can I reduce that? Yes, so that gives me negative square root of 30 over 10, and that's my answer. So that's super easy. That was just a reciprocal and rationalizing, no big deal. All right, so now on number 2, it gives me a tangent value, gives me a cosine value. I want a sine value. All right, so that's not a reciprocal relationship. That's the quotient relationship, because we know in general that the tangent of x is equal to what? Whatever what? Sine over cosine. Sine of x over cosine x. And remember, when you're writing sine, cosine, and tangent, there always has to be an argument. It's the tangent of x, or the tangent of theta, or the tangent of pi 4, or the tangent of something. Got to have something there, not just plain old tangent. All right, so knowing that, I can set this up. So tangent of x, so I know the tangent of x, it's the square root of 2 over 4. That's equal to the sine, which I'm looking for, sine of x, over the cosine, which is negative 2 square roots of 2 over 3. Now, fraction and a fraction is not new to us, but you have to be careful not to do something weird here. This does not make it difficult. This also is not a keep, change, flip situation. I do not care about the reciprocal of either one of those fractions at this point, okay? If it was a keep, change, flip situation, that would mean that that where sine of x is, that would be some number that I would want to simplify this fraction. Simplifying this fraction, that's why we keep, change, flip. That's not what I'm trying to do. I'm trying to get the sine of x by itself, right? So what I want to do is multiply both sides by the denominator, by exactly what it looks like, not by the reciprocal of it. So that means I'm going to get negative 2 square root of 2 over 3. I'm multiplying that by the square root of 2 over 4, and that's going to give me the sine of x. Does that make sense? It's just like if it said sine of x over just 3. We'd multiply both sides by 3, right? So we're multiplying both sides by that entire denominator. So then when I do that, so what's the square root of 2 times the square root of 2? 2. And what's 2 times 2? 4. So I end up with, now just, you wouldn't necessarily have to write all this down, but look, I'm going to get negative 4 over, isn't it still just 3 times 4? So can't I just cancel those out? And so sometimes it's better not to just multiply everything together, like look at what you have. Not that 4 over 12 is that hard to reduce, but if it was harder, it would just be easier to knock all that stuff out. Okay. We good? What questions you got? All right. So then number 3, we have the cosecant of beta, cotangent of beta, and I'm looking for the secant of beta. All right, well, I know that the cosecant is the reciprocal of what? Sine, okay? And I know that sine and cotangent are related. And technically, cotangent and cosecant are related also, because we could make all kinds of different identities on there, but we limit them and then we just manipulate what we have. Otherwise, we'd have so many, it would be ridiculous. So here's what I know about cotangent. I know that the cotangent of beta is equal to what over what is the quotient? What goes in the numerator? Cosine over sine. All right, well, they didn't give me cosine or sine, but they did give me cosecant, and we said that the cosecant is the reciprocal of what? Sine. So that means I know that the sine of beta is 3 over 7. Okay? So if I have the cotangent and I have the sine, can I then find cosine? Does that help me find secant? Yes, it does. Now, even though I know you know by looking at cosecant being 7 over 3, you know that sine is 3 over 7. I highly suggest you still write it down. I still write it down so I don't write the wrong thing down on something simple, all right, because it's easy to get this stuff all messed up. All right, so then that means I'm going to get, so I'm going to take my cotangent, which is negative 2 square root of 10 over 3. That's equal to the cosine of beta, which I don't know, over the sine, which is 3/7. Everybody understand where that came from? So now I have negative 2 square root of 10 over 3 times 3 over 7, right? I'm not multiplying by the reciprocal, I'm multiplying by the denominator, and that is equal to the cosine of beta. So these 3's cancel out, so the cosine of beta is equal to negative 2 square root of 10 over 7. Now, that's not my final answer, right? And this would be a case where if I needed to rationalize, which I don't, but if I needed to, I wouldn't because I'm about to take the reciprocal, right? So then from there, that's cosine, so that means that secant beta is equal to negative 7 over 2 square roots of 10. So I have to rationalize, so that gives me negative 7 square root of 10 over what? 20. Good. There's my answer. What questions do you have? Okay, we good? All right, so on the back, here's a new set of identities. Draw this. Let's see. So here's my little triangle. All right, so we're going to think unit circle. Unit circle. If this is from the unit circle, what is the radius? 1. And on the unit circle, what is the x value? Cosine theta. Good. Took second period forever. I think they thought it was a trick question or something. Then when somebody finally said cosine, they were like, oh, yeah, we know that. And then the y value is sine theta, right? So these are called the Pythagorean identities because they come from the Pythagorean theorem. This is all a true statement that we already know, right? And we know how the Pythagorean theorem works. A squared plus b squared equals c squared. So that means that the cosine squared theta plus sine squared theta equals 1. And that's true whether it's the unit circle or not. It just kind of takes care of itself in there. But so that's an always true statement. That's your first Pythagorean identity. That's this right here. Okay, this is the first one. Then we have a couple more. Tangent squared theta plus 1 equals secant squared theta, and cotangent squared theta plus 1 equals cosecant squared theta. Now, along with the reciprocal and the quotient identities, this one right here is definitely one you're expected to know. Okay, the rest, yes, I know you can get them all mixed up, but that one's kind of a commonly used one, something that you would just kind of be expected to make sure. I mean, you can always come back here and make sure it makes sense to you. But then when you have these, and this is how they will look. Well, actually, look at this and look at the Pythagorean identities on your yellow chart. Are they the exact same thing? No. On the yellow one, it says sine squared plus cosine squared. Does that matter? No, not at all. It doesn't matter either way, right? But there might be other times where you might want to manipulate this before you use it, meaning that if this is true, then it's also true that cosine squared theta equals 1 minus sine squared theta. Right? Because like I said, there's all these different versions of it. We could write even a different one. Here, I could just solve for tangent squared theta and say tangent squared theta is equal to secant squared theta minus 1. Here, I could say cotangent squared theta is equal to cosecant squared theta minus 1, right? Or even different manipulations of that. So just know it's okay to manipulate it before you use it. Right now, we're not going to. We're going to use them as they are. That comes a little bit more important later. But again, other versions of what's on there, there's a whole lot of stuff. Okay, we good? Questions? Okay, so this one, and again, here's where we have to make sure we read the directions. It says use Pythagorean identities. So it may be possible to use something different as we go through this, but this is what it is telling us to do. This is what we're going to do. Okay, so find cosine. We want to find cosine and tangent if, okay, so let's pause right here. Let me talk about your assignment. So your assignment, if you looked on the calendar, it says worksheet / Delta Math. So originally I took a worksheet that I had and I put it all in Delta Math, so it would be easier for you to like check your answers. But then I thought to myself, it's really something better to actually work on the worksheet, you know, just because I'm still, like I love Delta Math, but there's something about doing math on paper that I think is so important. So I'm going to give you the worksheet, but then you are going to go put your answers in there. But on a question like this where there's two answers, the way I did it was on the paper, I don't know what number they're on the worksheet, but like let's say it's number 4. In Delta Math, you're going to have a 4A, and then you'll have a 4B, and they just go in order. Does that make sense? It should make sense because the question pops up too. It's not like it just says 4A. But if you're wondering what the heck that is, that's what matches with it, okay? All right. Okay, so cosine and tangent. So I want cosine, got to do them one at a time. I want cosine, they give me sine. So I can use this right here, right? So I know that cosine squared theta plus sine squared, so that's negative 1/3 squared, that has to equal 1. Okay. And two things. I have to put parentheses around that negative 1/3 because it's negative and also because it's a fraction. Because if I didn't, the only thing I would be squaring would be that positive 1, and that's not my intention. Right? All right, so cosine squared theta plus negative 1/3 squared is 1/9 equals 1. Then I have to subtract 1/9 from both sides. Cosine squared theta, what is 1 minus 1/9? 8/9. Then I take the square root of both sides, so cosine theta is equal to plus or minus the square root of 8/9. Now, before I simplify that, I want to know, is it plus or is it minus? Which is really something we should have looked at before we started, but if we didn't, at this point, you got to go, oh, I got to go figure that out. You have to pay attention to what quadrant you're in. Just like on that first quiz that you took that I'm not quite finished grading, that was a hot mess for some people because you didn't worry about your quadrants at all. If I don't know what quadrant I'm in, I don't know if that's positive or negative. So if you're given a value, like here I'm given this sine value, right? I'm given this sine value and I'm told that cotangent is less than 0. So I say, all right, well I know that sine's a negative in 3 and 4. Tangent is negative in 2 and 4, so I am in the 4th quadrant. Okay. Since I am in the 4th quadrant, is this positive or is this negative? Positive. So that means in the end, my answer is cosine theta equals, what's the square root of 8 when you simplify it? 2 square root of 2 and over 3. There's my cosine value. We good? All right, so then I have, I'm looking, so I have cosine, found that, check. Now I'm looking for tangent. And so tangent, if I look at my Pythagorean, because it says Pythagorean identities. With sine and cosine, I could use a quotient identity, but that's not what the instructions say, and you would not get any credit at all for that. So we're supposed to use the Pythagorean identities. So tangent squared goes with secant squared. I don't have secant, but I do have cosine, right? So again, let's think smarter and not harder. Do I really care what just secant by itself is? No, I really want secant squared, right? Can I look at what I have and figure out what secant squared would be? Wouldn't it come from right here? Secant squared theta, what would that be? 9 over 8. Now, there's nothing wrong with taking this reciprocal and using it and then squaring it, but I've already rationalized it, and that just makes more weird stuff that I might mess up on, okay? But there is a part by using this that you might mess up on too. We'll talk about it as we write through it. So everybody understand where I got secant squared from? So it's fine if it's squared or even cubed to take the reciprocal of it also. When it's not okay is when it's like, I can't take the reciprocal of all of this and say that secant squared plus cosecant squared equals 1. That doesn't work because there's a plus or minus there. Okay. Oops. Goodness gracious. All right, so now that I'm here, I'm going to use this, and I know that tangent squared theta plus 1 equals secant squared theta, which is 9 over 8. Do I square that? Do I square 9 over 8? No, why not? Because it is secant squared, right? So that's the risk you take using that, is that you might accidentally square that. So think about it. I'm not squaring it because that is secant squared. You with me on that? All right. So now I subtract 1 from both sides. So tangent squared theta is equal to what? 1/8, yes. So tangent theta is equal to plus or minus the square root of 1/8. Is it plus or is it minus? Minus. I'm in the fourth quadrant, so it's negative. So that means that tangent theta is equal to negative. Well, the numerator, square root of 1 is 1. The square root of 8 is 2 square roots of 2. Then I rationalize, and that'll give me negative square root of 2 over what? There's my tangent value. What questions do you have? Anything? It's Pythagorean theorem. You just got to make sure. But if you don't know how to handle fractions, you don't know how to handle square roots, it really doesn't matter how easy it is. And I mean, at this point, I can't help you if you still don't know how to do those things. All right, so on number 5, I'm looking for tangent and sine if I have secant. So we're going to start with tangent. Is tangent directly related to secant in a Pythagorean identity? Yes, it is, right? Okay, so tangent squared x plus 1 equals secant squared x. So this time I do square it because I'm using secant and not secant squared. See the difference there? All right, so then this is tangent squared x plus 1 equals 36 over 25. So when I subtract 1 from both sides, tangent squared x is going to equal what? 11/25. Yes, good. It's 11 over 25. So tangent of x is equal to plus or minus the square root of 11 over 25. Well, I have to know, is it plus or minus? And we didn't look at that to begin with, right? So we're going to go back and go, all right, let's pause for a second. Let's see, secant's a reciprocal of cosine, and it's positive. Cosine's positive in first and fourth. Sine is positive in first and second, so I'm in quadrant 1. And everything's positive in quadrant 1. Okay, so that means that tangent of x is equal to square root of 11 over 5. Okay. What questions you got? Okay. So then I found tangent. I need sine, but I'm not using quotient or reciprocal. I have to use Pythagorean identities. So sine squared is related to cosine squared. I don't know cosine squared, and I don't know cosine, but I do know secant, which means I do know cosine. So cosine of x equals 5/6. And again, me personally, I actually write that down so I don't mess it up when I put it in. All right, so then I'm going to do cosine squared, so 5/6 squared plus sine squared x equals 1. So this is 25 over 36 plus sine squared x equals 1. So then when I subtract that, what is sine squared equal? 11 over 36, right? You gotta take make this into 36 over 36 and subtract that. So the sine of x is equal to plus or minus the square root of 11 over 36. Is it plus or is it minus? It is plus. So that's the square root of 11 over 6. And that is your answer. Okay. What questions do you have? Anything? All right, so let's talk about these identities down here at the bottom. So I took off the questions that deal with these numerically because some of them are just ridiculously weird and difficult and not necessary. We will use these some of them when we come back and deal with these a little bit differently. These are missing the fraction bars, so put these in here real quick. But so remember, sine is just cosine shifted over, or vice versa, right? So if you think about transformations, doesn't this just represent a shift? Okay, so this is just saying sine and cosine, they're just pi halves off when you get shifted over. Okay, that's basically what's happening. There's some reflection stuff going on in there, but it doesn't affect that one. And the reason it doesn't affect that is because of our even and odd identities. All right, so if you look at this first one, it says sine of negative theta equals negative sine of theta. So it kind of looks like the negative sign was just factored out, right? But that's not what happened because you can't factor that way. But this is what it's saying. So if I just asked you, okay, what is sine of pi thirds? What's the sine of pi thirds? Square root of 3 over 2, okay? And then the sine of negative pi thirds, it's the sine of negative pi thirds. Negative square root of 3 over 2, right? Okay, so see what this says? So this is the sine of theta. So it says the sine of negative theta is equal to negative sine of theta. See how that works? That's what it's saying. So look at cosine. Cosine, it doesn't look like it was factored out. Because here's what happens with cosine. If I say, okay, what is the cosine of pi thirds? That's 1/2, right? And then the cosine of negative pi thirds is what? 1/2. So whether it's cosine of pi thirds or cosine of negative pi thirds, it's still going to be 1/2. So if I said, what is the cosine of 4 million? It's going to be the same as whatever the cosine of negative 4 million is, right? But the sine of negative 4 million is going to be negative the sine of whatever 4 million is. Like, it doesn't matter what the angle is, okay? And that's by the nature of their quadrants and stuff. And so the only one that works with is like cosine and its reciprocal, where everything ends up being positive. And again, that's just because of the quadrants. But we'll look more into that. I just wanted to leave those on there because that's kind of where they get taught, but we're not going to do the numeric stuff. Okay? Questions? All right. So go ahead and tape this one in. I'll give you the worksheet that goes along with the Delta Math. And so there are 8 questions on here, so it goes up through 8B in Delta Math, but then there are a couple other little extra, like actual Delta Math things in there too, so don't forget about those.